Hello, Technograhis. By this time, you must have gone through the video lecture on precast concrete construction system, which is being used in Lighthouse project at Chennai. In this project, RCC structural elements are being cast in the casting yard and then assembled at site through cast in situ wet concrete jointing. In the e-module for Technograhis, we have also given you reference material in form of films, lectures, presentations, books, certificates, circulars, etc. And it is advised that you must go through them and use them frequently. This collection of reference material at one place you will not be able to get anywhere else. So keep a copy of it. Having gone through the lecture, there must have been several questions, queries in your mind. In order to answer your queries, what I have done here is that based on my experience and interaction with stakeholders on various platforms, I have created a section of frequently asked questions with common queries being raised, and that is what I'm going to present now. Normally, the framework of frequently asked questions have these 8 parameters: cost, structural performance, functional performance, joint and connections, design aids, codal provisions, schedule of rates, additions and alterations, maintenance of services, capacities in terms of professionals, agencies, and workforce. I will discuss and try to answer all these 8 one by one in the subsequent slides. But before that, let me just again summarize the project at Chennai. 1152 houses in G+5 configuration are being constructed here with the overall project cost of 116.27 crores, and the per dwelling unit cost is 10.09, including the infrastructure cost. So normally, whenever we deliver a lecture or whenever we interact with professionals, architects, and even engineers, public or private, the first question being asked is the cost, and that cost is always compared with the conventional cost of construction. So to put it on record, let me just tell you that the Lighthouse project, which is being done at Chennai, the per dwelling unit or per flat cost with precast concrete construction is 10.09 lakh as compared to 11.5 lakh, 56 lakh cost, which comes with conventional technology. So that is based on plinth area rate. If we calculate the cost of a dwelling unit, it comes 11.56. Whereas with this innovative technology, the cost is coming 10.09 lakh. That shows that it is 12% cheaper. So with precast concrete construction in the Lighthouse project, we are getting cost 12% cheaper than the plinth area rate. But let me also tell you here that in order to achieve economy in construction project, a critical mass, that is a minimum built up area or minimum number of houses, is must, because most of these technologies are based on a factory setup. So you have to set up a casting yard or a factory and mobilize heavy machineries and equipments to construct those houses. So unless you have a critical mass or minimum number of houses, the cost will escalate. This is also known in technical terms economies of scale. So more number of houses, the less cost will be loaded on the houses being constructed of equipment and machinery. So always bear in mind this critical mass. Let me also tell you here that if the technology is mainstream, then and there is demand, then cost will automatically come down. I know agencies, they are ready to set up a plant, a big plant, but if they continue to get business, then they will not load that cost of machinery and equipment on the cost of that specific project. To give you an example, here there is an example of BG Shirke, who are constructing more than 70,000 houses in Delhi for DDA. They are the agency who are doing these LHP projects as well. So what they have done, because they have got 70,000 houses in Delhi, so what they have set up few plants in Delhi and supplying those structural components at different places. So that thing one should always remember. Also, upfront cost cannot be told because these technologies are customized and your projects are quite specific. So cost will depend on number of other factors, such as what is the size of your project, what is the location, what is the geoclimatic profile? Is it in zone 4, zone 3 as regards earthquake? Is it falling in cyclone prone area? Or are you going to build in a soil strata which is soft or which is black cotton soil or marshy? Also, it will depend on availability of materials and a factory. Accessibility of site sometimes create a hindrance in um, making that technology available, because if you want to use precast concrete construction, so you require big trailers to for commuting and for transporting the materials. You require a open space where you can have a tower crane and other heavy equipment. So depending upon all these factors, your cost will be decided. But all said and done, I would say that cost with these new conventional these new innovative technologies will not be higher than 10%. But and at the same time, if the technology is mainstream, or if you give a critical mass or a minimum number of houses, it will come cheaper. There are other host of advantages which comes with these technologies. Resource efficiency is one, environment friendliness is another one, energy efficient. All these technologies are energy efficient because they use the embodied energy is less while manufacturing these components and using the sustainable materials. So overall they are cost effective. If to start with, they are not economical, but they are cost effective. And always remember, in times to come, we are going to have speed as one of the deciding parameters when we are doing a project, or deciding upon the technology. So speed of construction in these cases is quite good. If you compare speed of conventional construction with this, if a conventional construction takes 18 months here, you can complete the project within 12 months. As far as our LHP is concerned, Honorable Prime Minister laid the foundation stone for LHP at Chennai along with other 5 LHPs on 1st January 2015, 2021. And as of today, already there are 12 blocks in Chennai. For most of the blocks, the agency has reached to the 6th level. They have already constructed all the 6 floors for most of the blocks. So this is the beauty of the technology, because side by side, while doing the excavation and all, side by side, they set up the casting yard and started producing the components. And now once the foundation was ready, they have already started erecting. And erection takes, because it's a sequential and pre-engineered thing, it doesn't take much time and it can be done easily. Next question comes about the structural performance. Always we compare the new construction systems with what we have. We have cast in situ RCC frame construction with the infill of brick and other, and also load bearing structures. So structural performance, let me tell you without any hesitation that all these construction, the new innovative technologies, they exhibit superior structural performance. Number one. Secondly, the superior structural performance is ensured because you are doing the construction in the factory. So it makes a whole lot of difference when you do when you decide all the things at the site. Normally you need to have strict quality control and supervision. If you lack in quality control and supervision, you won't be able to get a good quality structure, and quality is directly related or directly proportional to your performance. So it's once you take the operation or construction into the factory, superior structural performance is already ensured. That is one thing. Secondly, whenever we are talking about precast concrete construction or precast structural elements or precast pre-stressed elements, always we use concrete of higher grade. And these are high performance concrete. So naturally, your structure will exhibit better performance. But at the same time, when we are talking about high performance concrete, you need to, have proper mix of concrete. You have to mix the ingredients properly, and you have to get the mix design done. Also, you have to do the trials with the mix design and try to achieve the target strength. Also, doing a project in the factory or making the components, structural components in the factory, the proper cover is ensured, proper detailing of reinforcement is ensured, the reinforcement cage is properly laid, and also you do proper curing of components. Primarily, these are concrete RCC structures. So curing, cover to reinforcement, detailing of that reinforcement, development length, splices, these things are very important. And all these things can be ensured, thereby improving your structural performance when you do the casting construction in the factory. Dimensional accuracy is another thing. If you go to any casting yard or any factory, modern construction factory, you will find all kinds of sophisticated techniques, modern techniques, and equipments are being used to cast these elements. In fact, the help of robotics and laser cutting is also being done in some of the factories. So the dimensional accuracy is at the highest. Let's talk about the technology which is being used in Chennai. This is the technology of BG Shirke, and they call it 3S technology. And 3S means strength, safety, and speed, and sustainability as well. What they are doing here, when they are casting these components, structural components, what they do, they cast hollow column, and they create notches in beam and columns, and they cast the slab which is partially precast. And at the beam, column, and slab joint, what is being done, because column being hollow, in the notches of beam and column, beams rest in the notches of those columns, and slab is also put there. And this slab, because it is partially precast, over this reinforcement, nominal reinforcement is laid, and then concrete screed is being done, and all the joints, all beam column joints and slab are cast together through the cast in situ wet concreting, thereby ensuring monolithic construction. So this is something which is very special about this technology, and this wet jointing ensure structural integrity and monolithic action. So all beam column joints, beam column slab joints, even foundation and column, all are wet joined with splices, development length, strictly following ductile detailing codes, if that is applicable, or otherwise IS 456 and other detailing codes. And then cast in situ concrete is put, and that concrete is also is of special grade, that is self, SCC, or self compacting concrete. So that ensures continuity of all the joints. So we can say, although it is a precast concrete construction, but all the entire structure acts monolithically, and the structural integrity is ensured. So these wet type connections offer excellent performance against seismic loads as well. I would also like to tell you here that nowadays there are the modern, modern and sophisticated structural analysis tools available, and with those analytical tools and using efficient design practices, we can always ensure better performance during service life structures. The common question comes here that these sophisticated structural analysis and these design practices are also available for conventional ones. But normally, when we do the construction with conventional technologies, we use prescriptive guidelines and thumb rules that may and seldom go for efficient design practices. Also, there is another thing that whatsoever we may do, unless we have good workmanship, unless we assure the quality at the project site, and unless we execute our project properly, we cannot achieve superior structural performance. So all said and done, even a good project which is designed, designed very efficiently, and if you're using top quality material, and everything is being done with checks and balances, but if the workmanship is bad, if you are not able to execute the project properly, or if you're not able to assure the quality of if you're not able to assure the quality of materials, in a way like reinforcement, let us talk about. When you're getting a reinforcement which is properly coming from the factory, and but when you are laying the cage, you are not laying it properly, that means you're not assuring the quality. Although you are getting a reinforcement which is good, which is tested, but while putting it in your structural elements, you are not putting it the way it is required. So quality assurance along with quality control is very important, and workmanship and proper execution is also very important to obtain desired performance of the structure which you are constructing. Now let's move to functional performance. Again, most of the time when we interact with the professionals, students and architects, they always ask, sir, these elements are thin, and naturally there will be more heat inside, and always it is compared with the brick wall. So this is a common question which is being asked. Apart from this, the question about fire is also being asked, because if you go to Indian standard IS 456, you will find that the fire rating of 1 to 2 hours is required, depending upon the height and size of the building, depending upon the thickness and the reinforcement. So that fire rating needs to be complied with. So these are two things which always being asked. So let me first tell you about thermal efficiency. Precast concrete elements are being cast with higher concrete, so which helps in improving that. So that concrete is dense, impermeable, and at the same time durable. And sometimes we use fly ash or GGBFS, and any other silica fumes. So all these help improve quality of concrete and make it thermally efficient. So always remember that high performance concrete help in improving thermal efficiency. But at the same time, whenever you are doing a project, again, it is given in code that proper orientation, good ventilation, locations of doors and windows, coupled with other passive measures, including climate responsive designs, are required to achieve desired thermal efficiency. In this particular project, if I talk about, apart from the structural elements which are being done in the factory, the masonry, the infill walls are of AAC blocks, and AAC is nothing but aerated or autoclaved aerated concrete blocks. And as the name suggests, their U value is quite less, and they are very thermally efficient blocks. So just by using this AAC blocks, make my building thermally efficient, and thermal performance is very good. Also remember that when we talk about any technology, most of the heat in the building comes from the slab or the floor. So if your floor is treated properly, if it is cast properly, and if you're giving a proper thickness of slab, and let's look into the technology, then you can reduce the ingress of heat in the building. So remember this, that if a proper thickness of slab is given with protective treatment, you can achieve desired thermal efficiency in any technique, any precast technique you are using. Fire rating, as I told you, there has been a lot of debate. So I always tell this: whenever you are doing a project with new technology or any other new construction system, all structural components need to comply with national and international code provisions for fire rating. So suppose we are doing a shear wall, the shear wall design. So what code says that if it is a residential building, the fire rating of minimum 1.5 hours, 1.5 hours for a thickness more than 150 mm. So that needs to be complied with. So there is no compromise with that because we find that fire, there are a lot of losses of lives as well as property because of fire. So fire rating need to be complied with. These being high performance concrete, being construction being done under controlled condition, and then execution is also being done in a sequential, proper engineering and mechanical manner, the structures which we produce using this technology are durable. And once you create a durable structure, you require less maintenance. So the life cycle cost is also um, reduced, or it is minimal. There is a question on compatibility with the other, because finishing items like how do we fix doors, how do we fix windows, what about tiles, what about WCs, what about taps and all. So let me tell you here that this particular precast concrete construction suits to Indian conditions, and all the conventional finishing items, whether it is plumbing, whether it is sewerage, whether it is your tiles, doors, windows, and WCs or commodes or taps, all these conventional finishing items, these technologies are compatible. The other functional performance, if I have to talk about low life cycle cost, in times to come, let me tell you here to all of you that initial cost of construction is not the only thing. The cost of the building during its service life is very important, and that is called life cycle cost. The cost being incurred while you are maintaining the building, and the energy being used, energy being consumed by the building, all these things matter. So you overall cost of the building should be less. So low, we need to aim at low life cycle costs. So cost of maintenance, maintaining the building, the energy demand of the building, all these things get reduced when we use high quality concrete, or we use this kind of technology. Let's come to joint and connection. Again, precast, several questions have been raised that most of the damages and collapses of precast structures are due to failure of connections, and therefore there is a misconception about the performance of precast construction. Let me also tell you, few buildings constructed with precast fell during earthquakes, and after that this was established by the professionals that precast construction is not good in areas which are earthquake prone. So let me tell you here that when we are talking about seismic zone 5, we are not recommending. India is divided into 4 zones, zone 2 to zone 5, and 5 being the most severe zone. So in zone 5, we are not recommending precast concrete construction, although it can be done with proper engineering and detailing, but we are not recommending it because of the factors I told you about workmanship, about quality assurance, about design. So it is suitable only up to zone 4. That is one thing. But at the same time, let me talk about the misconception. This is a misconception that precast construction does not fare good during earthquakes. In fact, it shows excellent behavior if you have proper joints and proper connections. Let me also explain you that in any building or any structure which you are constructing, the joints can be of 3 kinds. One is a dry joint, another one is a wet joint, and the third one is a mechanical joint. So dry joint is something which you do with nut bolts, fasteners, putting anchors, pasting base plates and connecting those base plates with welded plates, or with welds, or putting cleat angles and plates, and then putting it with nut and bolts. Okay, that is called dry joint. The other joint is wet joint, which is also known as emulative joint system. And this is the best, and my personal experience, and what I always suggest, that whenever we do precast concrete construction, always go for wet jointing, because you need to connect all the components, structural component, beam, column, slab, beam, column, foundation together. And to achieve monolithic construction, you need to have dowel rods connected and do the wet jointing, do the cast in situ concrete. So that is best, because that will ensure your monolithic action. But nowadays, with dry joint also, buildings are being built up. Another good practice when you are doing precast concrete construction is to that over slab, always put a reinforcement screed with reinforcement, and connect that reinforcement with the reinforcement of column and beam. That will ensure your structural integrity. And third the kind of joint is mechanical joint system, which is normally you find in steel structures or metal construction, whether you're doing with aluminum or whether you're doing with steel frame and all. There you have flange to flange connection, web to web connection through gusset plates, through fleet angles. So there you use nut and bolts. Okay, and so for me, web connection or emulative joint system is best, but with dry joint also buildings can be made earthquake resistant. Also, let me tell you here that dry connections are more suitable for panel walls and floor systems in low-rise structures. So whenever you are doing a low-rise structure up to the 15 meters or G+4 structure, then dry connections are more suitable. And wherever you are using lightweight concrete or lightweight panels, there it's more suitable. All said and done, here again, I have written, at the bottom of the slide, that proper designing and detailing of joint is must. Each joint, if you are making an important structure, high-rise structure, and in India is a country where we have frequent earthquakes, so all designs need to be properly designed. Once you arrive at the analysis results, so each joint need to be properly designed, and detailing of joints are very, very important. Detailing means that what is the reinforcement required, what would be the shear reinforcement, what should be the spacing of those tie, what should be the development length of the bars which are coming from beam columns and others. So that connections need to be properly detailed. Otherwise, even your good workmanship will not help if you don't detail and properly design your structure. So proper designing and detailing will help avoid failure of connections. Now let me move to design its codal provisions and schedule of rates. The common question asked is, these are new technologies, so we don't have codes. These are new technologies, so how do we design it? The good news is for precast concrete construction, there are huge number of softwares available. ETAP, SAP, SAFE, StatPro, Abacus. These are few which I know. In addition to this, I am sure there are a whole lot of other softwares available. And these softwares, give you wide range of, analytical tools: 2D analysis, 3D analysis, linear, non-linear, static, modal, eigenvalue analysis, dynamic analysis, time history analysis. You can just put the earthquake history and do the time history analysis. You can do the frequency domain analysis. So all these things can be done. Another good news is, in our times, these softwares were, based on international standards, but now most of these softwares are, they have also included Indian standards. So all you have to do is you model your structure in any of this software as per your requirement, and because they are also they have incorporated Indian standard. So what you get the analysis as per Indian standards, and you can design that as per Indian standards. Another thing for precast concrete construction, very recently, BIS, they have just revised these codes. So there are two codes which are available, available as for designers and for planners. Building design and erection using prefabricated concrete, that is IS 15916, and another one is IS 15917. So these two codes can be referred, and nowadays these codes can also be easily downloaded from the website of Bureau of Indian Standard, and you can go to manakonline.com and download these the standards. Also, there is National Building Code, which talks about functional performance, material, and fire, and all those sort of things. So NBC is also a must-have code, which as engineers, as architects, and as planners, we must have a copy of NBC, and all these codes can be referred for designing so codal provisions, a set of codal provisions do exist for this particular technologies. And for loads, materials design, fabrication, erection, we have a wide range of Indian standards. And always remember that for as far as Indian standards is concerned, most of the things are widely covered. But again, our code also says that in case of non-availability of Indian standard on a particular thing, our code our codes, Indian standard, the BIS does allow, does allow use of international standards and international practices. So please keep this in mind. In absence of Indian standard, international standards can always be referred. This is allowed by BIS. Okay. Also, BMTPC under Ministry of Housing and Urban Affairs to promote new construction systems, sustainable building materials, issue performance appraisal certificates to new technologies and new building materials, and that is again being referred in Bureau of Indian Standard, that in case a code or codal provisions are not available, you can always refer BMTPC's performance appraisal certificate. So for most of these technologies which we are covering in this technology module, for most of these technologies, BMTPC has issued a PAC certificate. And again, this PAC certificate can be treated as a pre-standard. So before getting into the Indian standard, it plays the role of a pre-standard. Okay. As regards schedule of rate, we were approached by professionals, especially architects and engineers, that in absence of schedule of rates, they are not able to use these technologies or not able to implement these technologies in the field. So the good news again is that CPWD is regularly publishing schedule of rates for all these new technologies, and CPWD being part of our ministry and being part of this mission of promoting and mainstreaming these new technologies, any new technology which is shortlisted by ministry and or certified by BMTPC, CPWD in due course of time they bring out the schedule of rate. And so for this technology as well, CPWD has the Delhi schedule of rates, and they have also published a document which can be downloaded from their website. For all the new technologies, they have published schedule of rate in a separate volume. So just to show you that, again, believe in our Indian standards, and a whole lot of standards available. And this slide was also shown to you when we were discussing the lighthouse project at Chennai in detail. So for all, whether you talk about loads, whether you talk about materials, whether you talk about designs, a wide range of Indian standards are available. So for loads, always remember 875 is the code which comes into part 1, 2, 3, 4. There are 5 parts, and it covers all the loads except earthquake load. So for earthquake load, the most important code is 1893, which is written here. Then for RCC, again, there is a wide range of code, but the most important code is IS 456-2000. And again, I call this code as a Bible. So Bible of civil engineers, and when you're doing RCC is IS 456. So always use IS 456. Always refer IS 456. And for other materials like for steel reinforcement, 1786 is the most important code. For mix design and all, 10262 is the code. And repeatedly, I tell you that being a seismic prone country, we need to ensure seismic resistance of the construction, and ductile detailing code, if it is applicable, need to be referred time and again. And ductile detailing code will help you, design and detail your joints and connections, which is very important. So 13920 can be referred and can be used to make your ductile detailing of joints. For foundations, again, if foundations are conventional, for raft we have a code. Then for shallow foundation we have 1080. For pile foundation we have codes. For machine foundation also we have Indian standards available. Another question being asked is, what about additions and alterations? Can we do additions and alterations at the later stage? So before I say that no, it cannot be done, let me tell you that why at all we require, why at all we want to do additions and alterations at a later stage, because that's a non-engineered way to do the things. Being myself a professional earthquake engineer, I have seen myself that the additions and alterations being done by people at their own, applying their own mind and engineering judgment, sometimes become very lethal during earthquakes. In fact, during Bhuj earthquake, I have seen that buildings which were badly made, not, which were altered, for waterproofing, they keep on adding the concrete layer and making the building heavier. Those kind of things were seen. So always avoid additions and alterations, because these buildings, you don't know in what way it is going to affect the overall earthquake paper. It may look good to you. You may find column very heavy for vertical loads, but by just addition and alteration, you don't know what will happen during the shaking of your ground. So you have to be extremely careful when we are dealing with earthquake loads. So additions and alterations at the first instance need to be avoided. But if at all you want to do additions and alterations, always take a help of an expert. The expert of that area means who knows how to do retrofitting, how to assess the health of the building. And let me also introduce a word called building pathology. Building pathology means, before doing any addition or alteration to your building, you need to understand the building's health. The building's health means what is the strength of the building, what kind of system does it have, if we add some components, what is going to happen. So all those things can be done with the help of expert. But again, the bottom line is it's a very expensive and time-consuming proposition. So let's not think of additions and alterations. Okay, and another thing, because all these technologies, whenever we are using these technologies, everything is pre-decided, pre-planned, and pre-engineered. So it is difficult to do additions and alteration at the later step, because that will endanger your joint construction and structural stability. Also, additions and alterations may change the load path. When we talk about earthquake, sometimes we have a balcony, and later at a later stage that balcony is converted into a room. So for vertical load, it may look good, because you will say that balcony was supported by columns, and so I have made a room. So what? But you are adding stiffness, you are adding you are creating irregularness in your building, you are creating a stiffness irregularity and those kind of things. You are changing the original load path of the building. So during earthquake shaking, it may be dangerous. Okay. Maintenance of services is the another question being asked. Again, for new construction technologies, always avoid at a later stage, if you want to change some services, it is difficult to do. So preventive maintenance, regular preventive maintenance is the answer, that we need to regularly check lines, conduits, water flow, and cleaning of blocked drains, which will help maintain the services during the service life of the building. Because if during the service life of building something goes wrong, it is difficult, because you have monolithic shear walls, you have connections, and also difficult to attend leakages and malfunctioning of the plumbing and electrical lines in these the systems at a later stage. So proper workmanship, proper installation of services is of paramount importance. But if you keep the record of your building and how you are laying your services, and also at a later stage, if you have those maps and all, you can do if at all it is required, you have to attend to some leakages, it can be done. But again, always go to a professional who knows about that building and who knows about that technology. And always remember, whenever you are doing, you are plugging a joint, or if you are repairing a column or a beam or a wall, always remember that you need to use a concrete of higher weight than the concrete being used originally in the structure. And that will help you in plugging the joints, and creating a joint. It is always, always remember, you have to join, or you have to, create a good bond between the old concrete and new concrete, and that can be done, by putting suitable connections between. Although you may create a void in the structure and then just plug it with the usual concrete, but that will not help, because you won't be able to connect your old concrete with the new concrete. So it has to be done with a higher grade of concrete, and plugging should always be done with non-shrink grout or special grout with the help of double bars and additional bars you can put and connect the older reinforcement with the new reinforcement and to the jointing. So you require expertise, and a normal contractor cannot deal with that when we talk about these new technologies. Last is the capacities. Yes, we do lack in capacities, whether we are talking about engineers, structural engineers, architects, whether we talk about agencies and workforce. So we need to create, we need to build capacities, and our Ministry of Housing and Urban Affairs, along with the BMTPC, we are making a concerted effort to build capacities in India, and we are running a course called Navriti, which is a certificate course to impart knowledge to the professionals on these innovative construction technologies. And also, the next step would be to get innovative construction systems included in the academic curriculum of academic and technical institutions, so that by the time you finish your engineering or architecture course, you know about these innovative construction systems. And it can be done. So capacities, and more people are now interested. Even in fact, all professionals, architects, they are willing to experiment and to make use of these new construction technologies which have been shortlisted, evaluated, being promoted by various organizations. Professionals are interested, and so capacities are slowly being built. As far as agencies are concerned, again, it's a kind of demand and supply and demand kind of thing. So unless we have demand, we will not have agencies. But now, thanks to the efforts by Government of India, and in the wake of Atmanirbhar Bharat and Make in India call, given by our Honorable Prime Minister, now lot of agencies, new entrants, startups, even fresh engineers and architects, they are joining the construction sector and venturing into these new technologies, and working with these large scale projects. But again, as of now, there are very few. If we have to talk about large scale projects, so there are very few agencies as of now who have this requisite expertise to execute these kind of projects. But the things are improving, and more and more people are joining. Workforce, again, the workforce, you require a special set of skills when we deal with this new technology. And precast concrete construction cannot be compared with conventional construction. In conventional construction of RCC, concrete construction, cast in situ, even a labor sometimes do the casting, and which is a non-engineered way, or which is highly unprofessional. So in order to have professionalism, you need to have a skilled set of people, people with the special skills, or skilled manpower is required. So skilled manpower for all these new technology is must, but it's not that the others cannot be trained skills. So normally most of the agencies, what they do, they come with few skilled manpower, and then they train the manpower at the site. There are agencies like L&T and all, they run their own training schools, where before taking up a project, they impart training to their workforce. Also, the unskilled labor which you employ in these projects, they also need to be trained on site, because here you're dealing with heavy machinery, you're dealing with heavy equipments. You have to hoist, lift, structural elements, then join them together, use a special kind of concrete grout. So even for unskilled labor, you require a little bit of training. So I hope with this I have tried to cover most of the doubts and questions being raised by the people and stakeholders, professionals, whenever we discuss, we interact with them. So I hope some of your doubts, queries, I am able to answer. But in case you have something else in your mind, in case you want to know something else about these technologies, you can always write to me on my email address, ska@bmtpc.org, and I will try to answer to the best of my capability. Thank you very much.